In this section, we're going to be working on recursive formulas, it looks like. So let's begin. What is a recursive formula? Or what's recursion? That's a basic programming thing that you'll need to know if you ever get into programming. So in a nutshell, if something's recursive, it depends on some prior knowledge. So for example, if you want the next value of something, you might need to know the previous value in order to compute the next value. So you just need some previous knowledge is the very general way to describe it, in my opinion. Okay, now how do we go about doing these problems though? Let's see what this problem set is about, or what this problem set contains. All right, number one, a sequence is recursively defined by a sub n is this guy. If a0 is square root 2, what is the value of a2? Okay, so as I said, a recursive formula, or something that's recursive, depends on a previous value. So you can see here, for some value a sub n, it depends on the previous value a sub n minus 1. For example, if n is 1, then it depends on a0. So a1 depends on a0. a2, when n is 2, depends on a sub 1, because 2 minus 1 is 1. So this is an example of where the next value depends on the previous value, as I was saying. Okay, so if a sub 0 is square root 2, then a sub 1, as I said, was n is 1. Okay, so it's a sub 0 squared plus 2. So what's a sub 0? It's square root 2. We square it, that becomes 2. So square root of 2 plus 2, which is square root of 4, which is 2. That's a sub 1. Now a sub 2 would depend on a sub 1. Because n is 2 now, so a sub 2 minus 1, that's a sub 1. Okay, and now, what is a sub 1? Well, we previously found it was 2, so it's 2 squared, which is 4. So this is square root of 6. So you see a sub 2 is square root 6, and that's the answer. Okay, next, a sequence is recursively defined by a sub n plus 1 equals a sub n minus f of a sub n over g of a sub n. If a sub 0 is 1, f of x is this guy, g of x is this guy, what is the value of a sub 2, okay? So more things to plug in, so you gotta be careful here. So if n is 0, then we get a1 is a0 minus f of a0 over g of a0. This one's a little different than this one, in that here, it's defined as the next term, it depends on the previous term, as we did. Here, it's defined a little differently, but technically you can move the terms around, the indices around, and you'll be fine. But to not confuse you, I'm not going to do that. But here you can see that they define it a little differently, but it's kind of the same. The next term is dependent on the previous term. Okay, instead of here it was a sub n, and it depends on a sub n minus 1. Here it's a little different. It's just saying the next term, n plus 1, depends on the previous term, n. So it's off by 1 index, kind of. But it's essentially the same thing. Same type of problem. All right, so let's continue. A sub 0, they tell us is 1. And then we would need f of 1 over g of 1. What's f of 1? That is 1 minus 3, which is minus 2. And then g of 1 is 2 minus 3, which is minus 1, right? So this still is a negative. It becomes 1 minus 2, which is minus 1. Okay, that's a sub 1. Now we need a sub 2, which is a sub 1 minus f of a sub 1 over g of a sub 1. Okay, now let's continue. A sub 1 we found as negative 1 minus f of negative 1 over g of negative 1. Okay, so this is minus 1 minus what's f of negative 1? That's 1 plus 3, which is 4. G of negative 1, that's negative 2 minus 3, that's minus 5. So this is minus 1 plus 4/5. Okay, which is minus 1/5 if I did it in my head correctly. Okay. Excuse me, next. f of x is this guy. What is the value of f composed of f of 2? Okay, so let's write it like how I recommend you write it. F of 2. So this is more about composite functions, but why is it in this recursion section? Well, it does depend on a previous value. Here it depends, this middle one depends on f of 2. We got to find that first. And then this outer one depends on whatever f of 2 is. So we got to keep evaluating things because it's dependent on a different value, basically. Okay, so what is f of 2? That'll be 2 squared, which is 4, times 2, that's 8, minus 1. 8 minus 1 is 7, so square root of 7. Okay, so f of 2 would be, it'll be 2 times 7, which is, because square root of 7 squared is 7, so 2 times 7 is 14, minus 1 is square root of 13. So f of 2 is, it'll be 13 times 2, that's 26, minus 1, that's 25, square root of 25, which is 5. Answer is D. Okay. A0 is the initial amount deposited into a savings account that earns a fixed rate of R% per year, and a constant amount of 12B is added to the account each year. Then amount A sub n of the savings n years after the initial deposit made is given by this equation. What is A sub 3? The amount you have in the savings 3 years after you made the initial deposit if blah, 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 blah. So you can see there's a lot of words that, as I was reading out loud, I wasn't actually paying attention to because I was eyeballing already kind of what the formula is and what they give us and trying to guess what they're trying to ask. So once you get very experienced, you'll know that a lot of times it's a waste of time, honestly, to read all this description. It's better to pick out the key points, but that comes with experience. But anyway, okay, so A is 0, B, R. That gives us, so A sub 1 would be when n is 1, right? So it will depend on A sub 0. We have B, we have R, right? So this is probably a calculated problem, but let's set it up by hand. A sub 1 would be 1 plus 5 over 100 times A sub 1 minus 1, which is A sub 0 times 12,000 plus 12 times 400. Okay. So then what is this? This is, can we do it by hand? Let's just do it with a calculator. I have it written down somewhere. I've solved this before, but it's been a while since I've solved it, so that's why I'm doing this again. If I did it correctly that time, it was 17,400, something like that. A sub 2 would be, so this part stays the same. This part changes though, because now it's dependent on A sub 1, because n is 2 now. Okay, so times 17,400 plus 12 times 400. That stays the same as well. So this is 2370. Okay, and then final time, because we want A sub 3, this is, by the way, this is 1.05. You could, instead of typing this every time you calculate, you could easily just do that. That's 2370 plus, and this is, by the way, what is that, 4800. Save time as well if you plug it into your calculator. This is 29023.5. So then that should be C. Okay. So you just got to be able to use those formulas carefully. The recursive formula. Number of gallons P sub n of a pollutant in a lake. So, okay, I'm not going to purposely read it. This is the formula that looks like recursive formula. Initial amount P0 is 400. What is P3? Okay, so let's begin. I didn't even have to read the whole thing. But we should be careful and read what the question's asking, actually. The amount, so they're asking for P3. Okay, so P sub 0 they give us. So P sub 1 is 0.85 times 400 plus 20, which if we plug into a calculator, you should get 360. Go through the motions. P2 is 0.85 times 360 plus 20. Plug it into the calculator. That is 326, and p sub 3 is 0.85 times 326, because we want the previous one, plus 20, which is, what did I write down? 297.1. Did it correctly last time? So the answer is A. Okay, and that's it for this problem set. So again, you just have to be able to be comfortable using these recursive formulas. Otherwise, it's not difficult, as you can see. Okay, as always, please like and subscribe if you found this helpful. And let's see what's up next. Sneak preview. Exponential functions. So we're going to go over that next in the next video. Hopefully see you there. Bye.